Okay. All right, here we go. Find your 8.1 notes. And while you're jotting some things down, let me point out, I put a note here, and if I have time at the end, I'm going to show you, I found a PowerPoint on this that I know you guys frequently ask me, when are you ever going to use this? Why is this important? And fortunately, inverse variation is very, very applicable in the real world. An inclined plane is a simple machine that demonstrates inverse variation. So you will get to see that. Recall, two variables, x and y, show direct variation if y equals a times x. Another type of variation is called inverse variation. So I thought, what would be a biblical connection to this? If you think of life equals God times the world, the more world you have inside of you, the less God is inside of you. That's inverse variation. Likewise, the more that you have God in you, the less of the world you have in you. So inverse variation essentially means when you have more of one thing, you have less of the other. They go in opposite ways. So this is called inverse variation, and it says two variables show inverse variation if they are related as follows. Y equals a times x. The constant a is called the constant of variation, and y is said to vary inversely with x. So you noticed in your homework that you had that 1 through 12 all, you were asked to practice direct variation to get that back in. I think it was from chapter 2. So we are going to combine inverse with direct variation. But here's another example I thought we could look at. It says the number of hours it takes for a block of ice to melt varies inversely as the temperature. So example is, the hotter it is, the faster, the less time it takes to melt, right? The hotter the temperature, the less time it takes. That's an inverse relationship. So it says if we use H is the number of hours and T is the temperature, and I have to tell you that where I found this, I just got it off the internet, H equals K over T. Instead of using A as the constant of variation, they used K. That's all. So it says if it takes 2 hours for a square inch of ice to melt at 65 degrees, find K. So you would start with H equals K over T. It takes 2 hours to melt that square inch of ice when it's 65 degrees. How would you solve this simple equation for K? Are you going to multiply by 65 or divide by 65? You're going to multiply because the 65 is in a denominator and we need it to cancel. So K is 130. So we did find K, but then what happens is, if that's how they relate to each other, you could then determine things like, okay, I need that ice to melt in, 6 hours. What do I need the temperature to be? Or I know the temperature tomorrow is going to be, we wish, 98 degrees. How long will it take that to melt? Okay, so in example 1, it says, tell whether x and y show direct variation, inverse variation, or neither. So here's what I need you to remember. Direct variation is y equals a times x, and that's what you reviewed in your homework due today. Inverse variation is y equals a over x. Now they both have a constant of variation, but they're both also solved for y. So when it says you're given an equation and then the rewritten you want to solve for y. And then you can tell. If it's y equals a times x, it's direct. If it's y equals a over x, it's inverse. So letter A says x times y equals 7. We need to solve it for y. So we divide both sides by x, and y equals 7 over x. So what type of variation is that? Inverse. Inverse. Good. Letter B, this one is already written in the form we want. Is this direct, inverse, or neither? It's neither. Why is it neither? This doesn't say y equals a times x plus a number. Do you understand that? For to be direct, it's y. It's not that it's just y equals. It's y equals a number times x. That's it. There's no addition or subtraction. All right, last one. I need to multiply both sides of that equation by 4. And then that's direct variation. Okay, do you see the difference between B and C? You can't have addition or subtraction of numbers in direct variation. Okay, in example 2, I want you to write these 3 steps down. This will help you in your notes. Step 1, find A. Step 2, write an equation with A in it. Step 3, answer the problem. So in example 2, it says the variables x and y vary inversely. When I see that, I immediately want to write down y equals a over x. It says x and y vary inversely. You guys, this is a very straightforward section. I think you'll like it. It says write an equation that's going to relate x and y. What we know, and they're always going to do this, they're going to give you the variables, and the only thing missing is a. So y is 7, and x is 4. What do you have to do to both sides of this equation to find a? Multiply both sides by 4. So a is 28. Notice that was step 1. Step 2, this is the one most students forget to do. And I don't want that to happen to you because you'll lose a point on your test or your quiz. It said, write an equation that relates x and y. So y equals 28 over x. That relates the x and the y. Step 3, answer the problem. Then find y when x is -2. So I want to read through the problem again because some of us are having a little difficulty with following directions and actually answering what you're being asked to do. It said, write an equation that relates x and y. So saying a is 28, a equals 28 doesn't have an x or a y in it, does it? So that isn't it. So you're asked to write an equation that relates x and y, and then you find y when x is -14. So you're asked 2 things. You need to pay attention to that when you're asked to do 2 different things. All right, try example 3 now on your own. I'm going to give you a head start on me. Example 3 says the variables x and y vary inversely. So look at example 2 to help you. And y is 15 when x is 1/3. Write an equation that relates x and y. When you do it, box it. Then find y when x is -10. So you should have 2 boxes when you're done. Now don't let it bother you when you have a fraction in there, because I can still multiply by that fraction. They cancel. So a is 5. So y equals 5 over x. And then it says find y when x is -10. Okay, any questions on that one? All right, example 4. The driving distance between 2 cities varies inversely with the average speed. So then when you get to these word problems, driving time varies inversely with driving speed. What I like to do is I like to just underline that information. So I know I have an inverse relationship. It's telling me the driving distance between Chicago and Minneapolis is about 400 miles. Letter A says write a model. The word model is another word for equation. Write a model that gives the driving time T in hours between Chicago and Minneapolis as a function of the driving speed R. So the first thing I'm going to do, so they gave me the letters to use, T equals A over R. Do you see where that came from? Driving time T varies inversely as the speed R. Now, you need to remember something. Distance is equal to rate times time, isn't it? Distance equals rate times time. The distance between Chicago and Minneapolis is 400 miles. Now that R and T are the same R and T in this, so if I solve this equation over here on the left for T, I would divide by the R. So this one was a little bit unique in how it was set up. What's A? 400. It's 400, isn't it? So it's T equals 400 over R. Letter B says make a table showing the driving time for average driving speeds of 32 miles per hour, 40, 50, and 60 miles per hour. So you're going to need your calculators here. So let's do the rate and the time. So here's what you're going to do. We have the formula T equals 400 divided by the rate. So on your calculators, you're going to do 400 divided by 32. I got 12.5. When you do 400 divided by 40, you get 10. 400 divided by 50 is 8. 400 divided by 60 is 6.66 repeating, so let's say about 6.7. So what's interesting is when you look at the table, the faster you drive, the less time it takes. And that makes perfect sense, doesn't it? Okay? That's the inverse relationship. So can you see like the real world applications here of inverse variation? The faster you go, the less time it's going to take. All right, here we are going to look at checking for inverse variation. The general equation y equals a over x for inverse variation can be written as, now here's how I came up with this. If you multiply both sides of the equation by x, that's where x times y equals a comes from. So if you can multiply x times y, and it always equals a constant, then that's inverse variation. And that's counterintuitive to me, because you're actually multiplying the two, when in inverse, it's a division. Do you see what I mean? Like, that can be confusing. So let's look at example 5 to see how this makes sense. It says the table compares the area A in square millimeters of a computer chip with the number C of chips that can be obtained from a silicon wafer. Letter A says write a model that gives C as a function of A. Well, what we want to do is we want to figure out, is this, since we're on the section of inverse variation, is it inverse variation? So what we're going to do is we're going to take A times, the capital A times C. So on your calculators, take 58 times 448, just to see that you're on the right track. I got 25,984. Now multiply the remaining columns. Take 62 times 424. When you're done, check it with the board with my numbers. So here's the deal. The area times the number of chips. Now they're clearly not the same number, but they're really hovering around what number? About 26,000, right? We had some below and some above. But roughly, we're going to say it's about 26,000. So A times C is about 26,000. If this says write a model, that means an equation that gives C in terms of A, you would need to divide both sides of this by A, and here's your model, or here's your equation. And now you can see it is an inverse relationship. The bigger the area, the fewer chips you have. Okay? Now letter B says, predict the number of chips per wafer when the area of a chip is 81 square millimeters. Do you guys understand that millimeters are teeny tiny? Okay, and when you're talking about a computer chip, that's teeny tiny, isn't it? Okay. So let's take 26,000 divided by 81. And when I punched that in my calculator, I got 320.98. But you wouldn't tell somebody that's how many chips you have. You would say that's probably around 321 chips. All right, any questions up to this point? It's very, very straightforward. We now have something called joint variation. Joint variation occurs when a quantity varies directly. Okay, now I'm using the word directly. Varies directly with the product of two or more other quantities. So if I write that Z varies jointly with X and Y, this means it's direct, but it's a product then. So it's Z equals AXY. In the second statement, P varies jointly with Q, R, and S. So that would be P equals A times Q times R times S. Okay, this is joint. Example 6 says the variable Z varies jointly with X and Y. So this is Z equals A times XY. Then they're going to give you a piece of information that tells you everything but A, and they did. They said Z is negative 75 when A is 3 and Y is negative 5. I would need to divide by negative 15. A is 5. It says write an equation that relates these. So Z equals 5XY. Please make sure you're boxing these on your homework and on the next quiz and the test. When it says write an equation that relates X, Y, and Z, make sure it's boxed that I know you know. Then it says find Z when X is 2 and Y is 6. And I got 60. Alright, I want you guys to try example 7 now on your own. I'll give you a head start. The variable X, notice the order, the variable X varies jointly with Z and Y. Also, X is 60 when Z is negative 4 and Y is 5. Find X when Z is 7 and Y is 2. Now on this one, did it ask us to write the equation that relates X, Y, Z? No. So notice I didn't box it that time. It wouldn't be wrong if you did, but it didn't ask. Alright, now I want to give you a head start on me. Now in example 8, we're going to do something called compound variation, where you're going to mix direct, inverse, and joint all together. So in letter A, try all 5 of those. Y varies inversely with X. B is Z varies jointly with X, Y, and R. C is Y varies inversely with the square of X. D says Z varies directly with Y and inversely with X. E says X varies jointly with T and R and inversely with S. So try those. I think you guys can do this. first two super easy. Letter A, y equals ax. B, z equals axyr. Letter C, who would like to try this one for us? If y varies inversely with the square of x. You really have all the tools. Yeah, Daniel?
The y equals a over x squared.
Yeah, that's it. Notice it did not say square root. I sometimes have students who put a square root, and I'm like, it didn't say square root. It says square, so that's x squared. Yeah,
I
Aurora?
have a question. Why on A did you do y equals ax?
I do not know, because that was inversely. Thank you. I don't know why I did that. That was inverse. Thank you. I have no good reason for that. Thank you. All right, how about letter D? Who wants to try this one? Z varies directly with y and inversely with x. Sarah?
Z equals AY over X.
That is right. Yay. You guys, this really is simple. Z equals AY over Z. All right, who wants to try E? X varies jointly with T and R and inversely with S. Alex, you want to try it for me?
I'm still confused about letter D.
D?
Yeah.
It's
Yeah,
directly
X,
with
X.
Y.
There's x. Yeah.
Oh. I don't know, you guys. I don't know where my brain is.
I don't know what mine is either.
Okay, sorry, I don't know. Hello. Thank you guys for being so kind to me too. It's an older person issue. Okay, yes. Z equals AY over X. That should not have been a Z. All right, sorry. All right, now Alex, does it make more sense? Do you want to try this one? Okay.
I don't know.
All right. Eddie, you want to try it?
X equals ATR over S.
Yes. See, jointly, the word jointly means it's direct, and inverse means it's in the denominator. All right, now I have another problem here, because I thought, okay, let's try to find other real examples. In kickboxing, it is found that the force F needed to break a board varies inversely with the length of the board. If it takes 5 pounds of pressure to break a board of 2 feet, how many pounds of pressure will it take to break a board that is 6 feet long? So again, what I like to do is, it says the force varies inversely with the length. So I'm just trying, you can circle, underline, you're looking for those key words. So the force varies inversely with the length. Now, it's always going to give me a pair or quantities together that the only thing missing is the A. So it takes 5 pounds of pressure, that's the force, and the length is 2. So I multiply both sides by 2, and A is 10. So F is 10 over L, and it says how many pounds of pressure, that's the force, will it take to break a board that's 6 feet? Well, that's 5/3. Now you wouldn't say, oh, it's going to take 5/3 pounds. That's 1 2/3 or 1.67 pounds.